A voltage regulator is an electrical device that maintains distribution voltage within a specified range of values. This simplified diagram illustrates what a typical voltage regulator looks like. The electrical components are contained inside a cylindrical housing that is usually longer than the housing on a typical distribution transformer. On the top of the housing are 3 bushings. This bushing allows the primary lead from the distribution line to connect to the primary winding. This connection is usually designated as line on a regulator. This bushing connects the lead from the tap changing mechanism to the distribution line. This bushing is usually designated as load on the regulator. The voltage regulator is grounded through this 3rd bushing. 2 additional features found on most voltage regulators are a control panel and a tap position indicator. We'll look at these in more detail in just a minute. Here's a voltage regulator installed on a utility pole. Notice the characteristic shape of the housing and the 3 large bushings located on top of the housing. Unregulated primary voltage is applied to the primary winding through this bushing marked line. Regulated primary voltage is supplied to the distribution system through this bushing marked load. The 3rd bushing is connected to ground. A nameplate on the regulator housing provides specific information about the capacity and wiring design of the regulator. Located on the side of the regulator is the tap position indicator. The indicator consists of a faceplate calibrated to show both increases and decreases in voltage. In this example, a primary pointer and 2 memory pointers are also a part of this indicator. This wire connects the voltage regulator to its control panel, which is located on the pole near the ground. Inside the panel is an analog computer. The computer is programmed to respond to changes in line voltage and cause the regulator to increase or decrease the value of the regulated voltage within a specified range of values. One way of identifying a voltage regulator is the manner in which it fits into the distribution system. A disc or other insulator is usually installed in the distribution line near the regulator. Unregulated voltage is applied to the regulator from a tap on this side of the insulator. A wire runs from the tap through an isolation switch to the line side of the regulator. Regulated voltage is supplied to the distribution system through a wire connected to the load side of the regulator. The wire also runs through the isolation switch to a tap on this side of the insulator. In most cases, each phase wire of a distribution line is attached to a separate voltage regulator. The regulators may be mounted on separate utility poles like these, or in some cases, 3 regulators may be mounted together on a platform. Voltage regulators are an important part of a distribution system because they ensure that a customer will be supplied with electricity at a usable voltage. A capacitor is an electrical device that can accept a charge, store it, and release it. The manner in which capacitors charge and discharge increases the efficiency of a distribution system so that more usable power is available for customer use. This simplified diagram illustrates the basic parts of a single-phase capacitor. It consists of 2 plates separated by insulation housed in an oil-filled container. One of the capacitor plates is connected through this bushing to the distribution line. The other plate is connected through this bushing to ground. Capacitors are very easy to recognize because they are square or rectangular in shape. The number of bushings on top of the capacitor may vary. These are 3-phase capacitors. In most cases, you'll find capacitors connected together in banks. Here, individual capacitors are connected together to meet the load requirements of a specific service area. The ability of a capacitor to counteract reactive power does a great deal to improve the overall efficiency of a distribution system. A capacitor's ability to store a charge, however, can present a considerable safety hazard to you and other T&D personnel. Capacitors do an excellent job of storing an electrical charge. In fact, they will remain charged even after they are isolated from a system. When working on capacitors, it is extremely important to your safety that you follow your company's procedures for discharging the capacitor before starting any work. This will ensure your